going to be a standalone scenario. Okay? Quadrilaterals. Making sure, yep, okay. So at the top here, I'm going to try to write as clearly as possible. So properties of quadrilaterals. And I will say this, it's basically four-sided polygons. Remember, we did triangles, then we did quadrilaterals, and then we're going to do pentagons at like more than four sides. So this is your title of this page, and I would strongly recommend you have that very visible, because this stuff should, I would strongly recommend, go ahead, strongly recommend you putting it on your study sheet. And I will group them up a little bit, okay? Okay, so the first one I will talk about is the parallelogram. Also referred to as the parallelogram. Okay, parallel sides are like this, two lines like that, and gram, it's just shorter. If you ever want to write it that way. And here, parallelogram is basically a slanted rectangle. So it's slanted like this. And here's where I'm going to use the red pen for the markings. Okay. If you have a red and a blue, it's better. If you have red, blue, and green, even better. No, I'm just kidding. Red and blue will do, or two different colors. So the first thing I want you to note is that this side here is parallel to that side. Anybody know what parallel means? Yeah. They're the same how? Yeah, Marcy. They're going in the same direction, they will never meet. Like this is a copy of this one. Like they will never meet, they'll always stay the same distance apart. Like they'll never meet. Okay. So if they have the same angle, the same slope, I don't know if you remember slope. So this line is parallel to that line. Okay. Grab a different color if you have. And so this is one property, folks. Two sets of parallel lines. Then you have that this side measures the same thing as this side. Okay? And that this side measures the same thing as this side. That's another property, by the way. I'm going to write it down actually in words in just a bit. And watch this. This angle right here is the same as which angle, if you could guess? The one that's opposite to it. So we just go one line like that, one semicircle like that. And this angle right here, watch how I'm doing it. I'm going double like that, right? You can go up to triple and more if you want, if you need to. But this angle right here is the same as this angle right there. How many properties are on this diagram right here? 3 properties. 2 pairs of parallel sides, 2 pairs of congruent sides, and 2 pairs of equal angles. You're like, right? You're not gonna have to remember this as long as you have this on your study sheet. So let's do the rectangle, and then I will write down. So rectangle right under this. It's basically the same except for what's going to be unique about a rectangle when it comes to the angles. They're all the same and they're all 90. Yeah. A 4-sided shape always adds up to 360 on the inside. 90, 90, 90, 90, right? So put a 90 everywhere. That makes this one unique. But you could still say that they have two pairs of opposite congruent angles. You can still say that. So now the markings again, parallel, parallel, and this side is parallel to this side, so that's still the same. This side is the same as this in terms of length, and this side is the same as this side when it comes to length. So look carefully and make those markings. These are the ones that they all share, right? Opposite angles are congruent, just like here. And then I will make another diagram where they don't share. So here we go. This is the first property. Opposite angles are equal or congruent. Congruent is the fancy word, and this is the symbol, right? Equal sign with a squiggly line. Okay. Next is two pairs of parallel sides. And the next one is two pairs of congruent sides. So congruent, what I mean by that is they measure the same. They're the same length, right? Parallel means they're in the same direction. They will never meet. So the three properties are right here, okay? And then the next one here, diagonals. This one is where it gets trickier. Diagonals bisect. What does bisect mean? Anybody? Bisect? It means cut in half. The diagonals cut each other in half, right? So if you, I don't know, somebody has a bag of chips. Hey, you want to bisect that bag of chips? They're like, what? Split in half, man. Half, man. Anyways, so do this here real quick. We're going to focus in on the diagonals. So this is your parallelogram, and this is your rectangle. And let's see, I'm curious to see if you're going to catch what I'm trying to say here. This diagonal, and this is another diagonal. So if you were to connect the opposite corners, those are called diagonals. And do the same thing here. Okay. And look at what I'm going to do here. This stretch right here from the center to the corner, this is going to be the same as this. And this one is going to be the same as this one. Why are they not all the same in a parallelogram? Because one of the diagonals is longer than the other. They're not the same in length. If you just picture it, right, if you were to squeeze it like this, there's one that's the longer one and the shorter one. So you can't all have the same markings. Watch here on this one. Are both diagonals the same length for the rectangle? Yes. So boom, 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 boom. They all cut each other in half, but all those sections, when they meet in the middle, they will all be the same. So that is a distinction between the two. Okay. I will add, just so you know, there's one long and one short diagonal. And this one, both diagonals are congruent. They measure the same. And I have to make I have to add a big note here, right there. Note, make sure you have this down. Yeah, I'm going to try to make it as short as possible. Diagonals are not perpendicular. Right, seriously, Mr. Dirksen, what's up with these words, right? I thought I learned them in grade 9 and I would never have to worry about them again. Let me zoom in. Perpendicular, okay? What does that mean, perpendicular? If two things are perpendicular, a street meets another street at a 90, usually they're perpendicular, right? Walls, a wall and a floor meet, they have to be perpendicular if you want that house to stand, right? This is the symbol for perpendicular. Meet at a 90. If you want to add that, meet at 90 degrees. Not. Parallelograms and rectangles do not meet at a 90. You cannot have a 90 degree in there. Then it will cease to be a parallelogram or rectangle. So maybe if you have a highlighter, this should probably also stand out. Okay, now if you have a ruler, great. If not, I will cut this now, and so that we can have our next two shapes. So we'll just do one of these. Okay, so we're done with these two. For now, we're gonna put them in the back burner. There, and the next one you have your rhombus. This is basically, watch this. This is a square that is slanted sideways. A rhombus is a square, so try to make the side lengths all the same. So we have this. Let's call it first rhombus. Okay. So this length is the same as this, is the same as this, is the same as this. So that no surprises there. It's a slanted square. Watch this. This line is parallel to that line. This line is parallel to that line. So that still stands the same. Watch this. This angle is the same as the angle across from it. I will usually only make you have two properties on there if I ever ask you to sketch. This one is the same as this one. Can you see that? Let me zoom into that because I'm gonna. How many properties are on there? 3. Side length, parallel, and angles. Okay. Let's do the square. They're cousins, right? I do them by cousins, right? A parallelogram is a cousin to a rectangle. Rhombus is the cousin to a square. That one, I think we all know exactly what's happening. All angles are 90. All sides are the same. No surprises there. This side is parallel to that side. This side is parallel to that side. So with quadrilaterals, we have a lot of the parallel side thing going on. That's that. Also 3 things right here. 3 properties are present right there. Now, all sides are congruent. Opposite angles are congruent. Diagonals. Oh, watch this one. Diagonals. Can we wait with diagonals? Sorry. Messing up your notes already. Okay. 2 pairs of parallel two pairs of parallel sides and then here diagonals bisect. Bisect, and the next one is diagonals are perpendicular. Might be a bonus question. Spell perpendicular. So go off to the side with me once you have that. I'm gonna draw, so let's do a rhombus here. And the square here. Let's not worry about anything other than the diagonals on this one. So draw your long one and the short diagonal like that. Same here with the square. And for both, watch this, for both you can do this. There's a 90 here and there's a 90 there. Question, is it you should understand that it's 90 everywhere, right? I'm not going to put a mark on every single one. So, and then what happens here is that for this one is the same as that, and this one is the same as that, right? So they bisect each other, they cut each other in half, but they're not all the same. Whereas our square actually cuts everything, and every stretch of that diagonal cut in half is going to be the same. Okay, and I don't think it's a big surprise, but sometimes you have to know what's happening here, because I'm going to ask you to sketch quite often. It's like, hey, sketch this, and make sure there are two properties on that sketch. Okay, and the last one on this page here, page 190, trapezoids. They used to have a page on here, by the way, and it was terrible, right? Like students are like, pulling their hair out. So that's why, like, this is like my summary of all these shapes, so you don't have to guess. Okay, so trapezoids, you have the isosceles trapezoid. Anybody know what a trapezoid looks like? Some classrooms will have desks that look like trapezoid desks. So it's this one. It's basically a triangle, right? But the top was cut off, right? So that's what. I want to finish this page, okay? So whatever it takes. So this side is the same as that one. That's where the isosceles comes from. Two sides are the same. This side is parallel to that side. Obviously not the same length, correct? The top and the bottom not the same length. This angle right here is going to be equal to this one up here. And this one down here, I can't just put one down because then you're saying these are the same, right? Is going to be equal to this one on the opposite side. That's all I've got there. And then this one is the right trapezoid. You get to rest tomorrow. Unless you're working, of course, and you don't. And right trapezoid is basically, right, where one is cut off, like it's almost like one side was like cut off again. So you have your 90 here, of course. That's where the right comes in. The bottom is parallel to the top. And that's it for that one. Okay, so let's talk about what they have in common. One pair, this is one pair of parallel sides. Yeah. This angle? Yes, down the road we will solve for angles, but this is all we know about it for sure. We don't know that these are the same, right? Like it will actually never be the same. But there's something that I'm going to add at the end that's going to help you big time. One pair of parallel sides. That's the only thing they have in common. And then specific to this one is one pair of congruent angles. Sorry, two pairs. Two pairs of congruent angles. And one pair of congruent sides. That's like specific to this one. Doesn't go for the other one. Okay. And this one just has one pair of right angles. Specific to this one only. So this one they share. This is specific to that one, and this is specific to that one. And now, the concluding, if you have a red pen or something, this is where you want to add it. I'm going to go top from the bottom up, okay? What do these two add up to? 180. Actually, it turns out that for all of our quadrilaterals, if you were to add up those two angles here, it always adds up to 180. So the beauty is that if you know one of them, subtract it from 180, you get the other one. So we're going to go up. As we go up, we're going to add that fact that both of them always add up to 180. Same with the rhombus. That's going to be so helpful. When they give you only one angle, you're like, I don't know what to do. Oh, the bottom is 120, the top is 60. Boom, got it. Same with this one. So just make point to it. So 180 everywhere. By the way, it counts for both sides. Okay, so if you want to do like the same, I just don't want to fill it up too much. But look at the right trapezoid way down in the, maybe I'll do that one because you won't think that it is necessarily true. These two angles also add up to 180. So if you have like a 20 here, you know this is 160 up here, right? It's very helpful. What do all four angles always add up to, you think? I talked about it already. All four. 360, yeah. Because if this is 180 and this is 180, 360, right? So if I gave you 3, you could find the fourth that way, perhaps, right? Think there's a kite yet? Yeah, there's a kite. It's 35, so we still have time. Then you have them all. You're with me? Yeah, you're writing this down? I hope so. It's so exciting, I know. Quadrilaterals. What did you learn today? Your parents ever ask you what you learned today? I always ask my kids and they're like, nothing. Didn't learn anything today. Oh, really? You learned nothing. A kite is like this, a triangle there and another triangle at the bottom, but they're not the same. So watch this. Maybe what you could do is make this triangle and go dashed line across. Okay? It's an isosceles triangle, folks. And then imagine that you're stacking another triangle underneath it. But right, these two sides are the same, not the same as the top. Okay? If these two sides had been the same, what shape are we talking about? If all four had been the same. Rhombus, yes. It's no longer a kite. It's actually specifically a rhombus. Okay? So watch this. Make a diagonal across like this. What do you think they meet at? At a 90. So they are perpendicular. Okay? So I think we can manage that, right? They meet at a 90. So here, I want you to think of it as two isosceles triangles stacked. This is just me. Okay, so let's not make that a property. So I won't make that a bullet. Okay, so I'll just go like quotation like that. Two isosceles triangles stacked. Okay, and we know that the property is two pairs of congruent sides. That's one of the properties. Shorter diagonal bisected. Not both, Mr. Jackson? Nope, just the shorter one. Which one is the shorter one? You can clearly tell that it's this one, right? So you can do this. It's cut in half there. And diagonals are perpendicular. They meet at a 90. And they also have one pair of congruent angles. I hope this mean you know that this means angles. If not, write down angles. Okay. So I will do this. Another kite, just a quick, because I don't like to have them all the same. This angle is the same as that one. So right, I'm giving you a separate diagram just denoting that these are the two angles that are the same. Not these ones, guys, okay? These ones are not. At the top and bottom, those are not congruent. Okay? Remember? Sum of interior angles is always equal to 360. All of these quadrilaterals is always 360 if you were to add up all four sides. And I'd like to at least give you two examples of what I expect of you, and probably Monday, if I asked you, sketch me a rectangle and identify at least two properties. What would it look like, right? So cut it here. That's it for properties. I need you to be able to sketch. And you use markings, right? So sketch a parallelogram, label two properties. Give me three versions of that diagram. If I asked you for three versions of that diagram, what would it look like? I don't want you to just leave without anything to go with. Parallelogram looks like this. This is version number 1. Label one property. This is one property. Parallel. These two are parallel. These two are parallel. Property number one. What else can we say? That this side is the same as that side, and this side is the same as this side. That's version number one. You've done it. You got 2 out of 2 marks there. Not too bad, is it? Version number 2. I choose to, in this one, talk about the fact that this angle is the same as that angle, and that this angle is the same as that angle. That is property number 1. Property number 2, I like to talk about the fact that these two are parallel. You catch the idea here? 2 things that are true about it. Version number 3. Either one of these would give you the full marks. I will talk about the diagonals here. This diagonal and this diagonal, this right now gives you 0 marks at this point. But if you say that this is the same as that, and this is the same as that, now we're in business. You're saying that the diagonals bisect, but you're still not getting the full marks. One more property. This side is the same as this side. This side is the same as that side. Now you have the 2 marks. Okay? That's what I mean by that. Thank you very much, guys. You have yourselves a very good long weekend, I should say.